All right, so last time we left at Zookeeper, and let's start with other auxiliary tools such as Scoop, Flume, and these tools are used for various kinds of things. And we are going to discuss in detail these tools today. Okay, is my voice feebly audible? Good, good. Yeah, so actually, yeah, one few things were left in the last session. Let me just quickly cover those aspects. Hmm. All right, so we were here on this. Okay, all right. So these are the kind of consistencies which Zookeeper provides. Again, let me just recap Zookeeper very quickly. When you are building a distributed computing system, or maybe you are building an application which runs on multiple computers simultaneously, for coordination between these services, you could store your flags, various kinds of small data, into this service called Zookeeper, so that your system can coordinate very well. Just like if you have done multi-threaded programming, you have these shared variables which can be utilized. All right. So in the same manner, Zookeeper comes into play. All right. So the role of Zookeeper is exactly that, and various services use it. And in case you are building an application or you're building a tool which requires coordination, which runs on multiple machines simultaneously, and these multiple instances of the same code, if they require the coordination, they can utilize this kind of service. All right, and there are multiple use cases of this uh, Zookeeper, and that is why it has been covered. Okay. There are various kinds of guarantees it provides. Sequential consistency. Updates from any particular clients are updated in the sequence. Okay, which means that uh, if I am making some changes, I'm writing to Zookeeper. Whatever changes I write, they will always in the sequence. Okay. Then atomicity, then single system image. So a client, whosoever is the user, will see the same view of the system. And durability and timeliness. Okay. So these are the basic guarantees which Zookeeper provides. And also other than this, Zookeeper gives you something called services. Uh, it gives you a session. Session is just like any other sessions you create with database or any other TCP/IP connection. So when a client is connecting to a Zookeeper servers, the list of servers we call it ensemble. Out of ensemble, a leader is chosen, and that leader is called leader, and others are called followers. So the client has a list of servers in the ensemble, and rest of the servers it gathers using the existing servers. It asks that what are the other members in the ensemble, and all of that information the client gathers automatically. And the client starts with one machine. When it's trying to read, it will try to read from one and will keep on trying others if it is unsuccessful. Okay. And every time a client connects successfully, a session is created by the server, so that an expiry could be placed. As in, if the client disconnect, then the session would get expired. Okay. And also, in case client does not respond in timely manner, the session would get expired. This way, this way, server knows that which are the active clients, how many clients are currently active. And as soon as the server expires, the ephemeral nodes will disappear automatically. And it's a duty of your client library, the one which we were using for demonstration was Zookeeper client, is the duty of that client to keep informing server by sending heartbeats. Okay, in form of pings, it keeps on sending the pings or heartbeats and keep on telling the server that, hey, I'm alive, so don't expire my server session. So the client keeps on telling the server that I am alive, don't expire the session. Okay. And in the midway, if a server goes down, the client will immediately connect to another machine. Client will immediately connect to another machine, but the session will be retained. Session will not be destroyed if there is a connectivity problem between client and server before the expiry of the session happens. All right. And this failover is handled automatically by the client library. It will keep on connecting, and generally this failover is fairly hidden from the end user who is using the client library. And end user will always think that it's connected to the same server and is happy in that sense. Okay. But under the hood, the client library will keep shifting from one machine to another based on the availability, and that is how a HA or high availability is maintained. Okay. But having said that, although the application will be fairly agnostic what is going under the hood, which machine it is connecting to, whether there has been a glitch between connect, it is fairly agnostic. The application which is using the client library is fairly agnostic, but the application should make sure that in case it's writing something, there are chances that the client library is in transit, as in it's in midway. It has just disconnected from one machine, is trying to connect another one. So there could be a minor glitch in these rare occasions. Okay, so application cannot be totally agnostic about the internals. Application needs to make sure that in case a read or write fails, it might have to retry again. So I have not used EC2 Spot instances, but I would like to compare it with that. Okay, I'm responding to Swati. So let me just note it down. Now, the state while connecting to a server is looks like this. The client creates a new Zookeeper connection. Okay, and as soon as the client connects to the server, it gets a keeper state and so on. Okay. and the server will send a watcher event saying that connection has been closed. So these are the various states between connecting, connected, and closed. Okay. Basically, while creating the connections, this is what happens. These are the three main states. This one we had discussed that Zookeeper can facilitate clients discover the servers and ensuring a load balance in this way. Okay. Now here is one flow. So let's imagine that on the right hand side is your Zookeeper. Okay. And there is this client on the right hand side. And on the left hand side is the server. Okay. So this is your Zookeeper. This is your client and this is your server. You have hundreds of servers, okay, in order to give a load balance, and there are millions of clients. Okay. Now the client, so server and client both connect to Zookeeper before making the connections. So let's imagine that there is this server which basically connects to Zookeeper, says that connect to this host. This is my timeout, and this is my watcher handler. Watcher handler is the mechanism by which the Zookeeper will keep telling the 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 client to the Zookeeper. So both the ways, this or this, both are clients to the Zookeeper. But in our use case, these are our servers and these are our users. Okay. Now once that happens, the moment watcher event connected is raised, the server will receive the information that I'm successfully connected, and after that this machine will inform Zookeeper to create an ephemeral node called duck. Okay. Similarly, another machine will create cow under servers list. Basically, it's giving its own IP address or name, and that too is a ephemeral node. Okay. Now, at this moment, there will be two folders under servers, duck and cow. And when the user comes in, it says, "Give me the list under servers." You'll get duck and cow. And in case duck server is killed here, as in this goes down, and and user comes in, it will only get cow in return, and it will connect to cow. Here it has a choice to connect to duck or cow, all right, and get the results. So this way, a high availability is maintained using Zookeeper. Okay, so we had seen this example quickly last time. You want me to go through it again? So yes, you can think of Zookeeper. Zoo, Load balancing is just one aspect of Zookeeper. That too, Zookeeper is not really much of a load balancer. You can say that the load balancer application can use Zookeeper, or I mean, in lot of circumstances, it does act like a load balancer. Okay. But there are many applications which you can build around Zookeeper. Specifically, if your application requires, say, imagine that you wrote some application which was fine, which was working fine on a single machine, and now you need to move to different machine. And out of this, you suddenly need to have various kinds of things to be coordinated with other machines. In those cases, Zookeeper will come pretty handy for you. Okay, so let me again go to the same screen. So Ranjit's question is, what happens if after getting response of duck and cow, duck goes down, Will it first try to connect to duck, and if it fails, yes. So this dynamics, what to do with the list of servers, is the user, up to the user what they want to do. Okay. Zookeeper has done its duty, that it has given you a list of cow and duck, and rest is up to the end user. Okay. Ideally, if I am the client, what would I do is I'll maintain duck and cow, and we'll try to connect duck and cow one by one. And if I get a response, then if I don't get a response from duck, I'll connect to cow, and so on. Right? All right. So this hands-on was clear last time, or do you want to do it again? So I connect to my Hadoop one, run the client. Under the client, the prompt of Zookeeper client, I say ls slash. It means give me the nodes at the topmost level. And create slash class means create a node, z node called class. Under slash means under the top level one, with this data called type equals online. This is one data, and you can parse it accordingly. And similarly, you can create another node under class afterwards. Here you can get the data of slash big data slash class slash big data. You can use this kind of command, and you will get tag and other information. And also there is a set command, okay, but there is no such thing called update command, okay, as in if you want to append something to it or change a number or anything, the whole value either gets set or get deleted, or you can retrieve only the full value. You cannot do it partially. Okay, that is why Zookeeper is not really great when it comes to a lot of data storage, because it's not designed for handling lot of data. It's just designed for handling little bits of data, little bits of signals, little bit of information. Okay, few kbs of information you can think of. So there are many use cases like building a reliable configuration service. So at Amazon, when we all application needed a single service kind of thing, meaning whatever configuration we put it at one place, it should be reflected everywhere. So we had built a similar kind of thing on top of our Dynamo, but its objective was exactly the same, providing a configuration service to all the clients, and this configuration service runs on a lot of nodes parallelly. So if you have to build a configuration service for your application, you can use Zookeeper. Okay. And similarly, a distributed log service is something which people have built using Zookeeper. As you can also see that almost all the components in Apache ecosystem, they all are moving towards using Zookeeper for coordination rather than building their own coordination systems. Like like now HBase uses uh, HBase uses the Zookeeper for coordination, and there are multiple more services which are coming every day which utilize this as a coordination system. So that's pretty much about Zookeeper. All right. Any questions on Zookeeper to me? Any questions? Okay, that's good. That's good. Sushant's point is that how frequently should we be concerned about Zookeeper functioning for coding MapReduce? So there would be some problems in which you would like to utilize. Let's imagine this. Using MapReduce or distributed computing, what you have built is you have built a system which downloads data from various websites. Okay. Now, or you can think of, there are, every day you create a list of 20,000 web pages, and your MapReduce is nothing but they are crawling various websites. Each mapper is basically crawling a section of the list. Now, what if the we want to put a restriction that don't hit a website more than twice? Okay. Don't hit a website more than twice in last 2 seconds. All right. Now, these crawlers need to coordinate with each other. If one mapper is utilizing one domain name, you want the other mapper not to hit that website. Otherwise, if there are all mappers are hitting the same website, it will be difficult. Okay. And why could you not deduplicate it? Because these are full URLs. These are not only the domain names. Okay. So these are different URL, though they are same domain names. And we do not want a domain name to be hit by multiple services at the same time. To do that, your mappers might be utilizing a coordination service like um, Zookeeper, so that each of the node, when they start downloading the data from a website, they just mark that, hey, I'm downloading this data from this website, and they mark it in Zookeeper. And the other ones, before hitting the websites, they first ask Zookeeper that, hey, is this node existing? If it's no node existing, then they won't hit it. They won't touch that um, server, and they might touch it later on. Okay, so there are many ways you could utilize Zookeeper specifically for coordination. Okay, so that is Sushant. Yeah. Okay. So I mean, and I have seen exactly the same problem. So we had this grand mechanism of running our code on, say, 200 machines. So when I was doing image optimizations, if for Amazon's detail page, there is a big image that comes in. That image has to be selected from few hundred images. So that has to be pre-computed before displaying on the Amazon.com's website. So I would like to share this case study with you. Okay. So what happens is, lot of vendors keep on updating the information on Amazon.com's website. So as soon as we receive and this information, so there we have Amazon has provided this UI to all the vendors of Amazon, from where they can update their product images and other information. Now this information goes into an event bus, a central event bus, which is called SQS. Amazon provide this as a service to on their cloud as well. So it's a SQS system on which all these events are pumped into, that this particular detail page has been changed by this particular vendor. Now we were reading this big SQS. Okay, so we were reading from this SQS, and I'll actually try to draw today. I'll try to draw today. Okay. So imagine this. There is this big pipeline, and and this side, this side, there is one vendor. There is another vendor. There's another third vendor. They're all making some changes, and they're all making some changes, and their changes are being pushed to this queue. Okay, and on the other side of this pipe, we have set up small machines. Okay, we have set up. Can you hear me? Because it shows me there is some connectivity problem. Okay. So we have set up these small servers which basically listen to this queue, okay? And then all of these servers would be fetching data from a central database and then putting. So let me just draw one more diagram here. Okay, so this is one, and let me just draw some more cool stuff. Okay, so these are our computing machines, and this is our global catalog, and this is our final image link. You can think of this. So basically, I will draw you a few more things. So now, although in the diagram it looks really complex, but if you think about it, it's pretty simple. These are our vendors. Hello. 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 Yeah. Is it audible now? I'm having a lot of problems this side. Are you? Is it clear? Okay. Okay. So yeah. So let me discuss this case study for you. All right. And I'll read out one comment from Seema. The arrow from the bus to computing machine is pull. Does the bus have the info which machine? No. Actually, what happens is the way this generally the event bus. These are the event buses in which packets are being pushed into. Basically, packages are being pushed into this event bus, and it's not only one vendor. There could be multiple kind of machines which are listening to it. So it just so happened these are, say, 30 machines were dedicated to me. Okay, these 30 machines were pulling data continuously from the queue. Similarly, there could be a 10,000 more machines listening to the same queue. Okay. The dynamics is dynamics is the moment you pick up a packet from the queue, that packet will become invisible immediately to other people. Okay, so only one person can read a packet from a queue, and that will become visible again after a timeout. If the user has not deleted that particular package from the queue, it will be assumed that nobody could read it, and therefore that packet will become visible in the queue. Okay, in queue it looks like flowing, but it's actually a big hash table from which people keep on reading the data. Okay, so computing machines are reading from it. They say inside each computing machine there is a infinitely for loop running which keep on saying q dot read or q give me the data continuously. Okay, that's an infinite loop running in all the computing machines. Okay, now right. So you in this diagram, you can see that there are vendors, they're pushing the changes. Now computing machines are picking it up, and what I wanted to show you, the computing machines read the changes, understands, and then talks to other data vendors in organization to get more information about the image which we are talking about. Okay, it gets the information from the global catalog, and there are five different catalogs from which it retrieves the information. And after doing that, after finishing computing all the computation, and then it finalizes an image that this out of these images for this product, this is the image which looks the best, and then pushes it into this node. Okay, then it pushes it into another system saying a big basically EC2 saying this product has got this final image. Now all of both of these surveys, this global catalog as well as this, both have said that in case you try to hit us more than 5 times in a second, we are going to blacklist you. Okay, so if all of these machines start hitting this same global catalog at the same time, okay, it is going to blacklist you, and hence it is going to hurt pretty bad, right? Therefore these computing machines need to coordinate with each other so that they do not hit the global catalogs beyond a particular frequency. And this coordination that the we should not be hitting a global catalog beyond these many numbers was done using another way of coordinating. Okay, so whenever there are multiple computing machines, they're hitting some service, you would require a coordination. So we needed a different kind of a coordination system similar to Zookeeper in order to make sure that we do not hit global catalog too many times. Make sense to you? Because all of these machines will try to hit global catalog all the time, and that will and these are the way in organization the most of these blocks do you see, they are essentially a service exposed to the people, specifically in case of Amazon because they were pioneers in case of a service frameworks. So everything is a service, and this service has defined an SLA. These service have defined number of hits beyond which you cannot access them. So so that is where you're in these between these computing machines you would require a coordination system. All right, so what I did in these cases, just like in case of a Zookeeper, what I did was anytime Anytime a machine starts hitting the global catalog, they create an ephemeral node with their name. Each computing machine will create an ephemeral node with their name under a root. Okay. Under a root, each one will create their ephemeral node and then delete an ephemeral node as soon as it finishes reading from global catalog. Once that finishes the reading from the global catalog, it will remove from Zookeeper. And in case at the same time, before starting to read from global catalog, other machine will first look up which all machines are reading from global catalog. If the number is beyond some time, the machine will wait, okay, and hence and then it will go. So makes sense, right? So the computing machine, before it starts the job, it marks itself in a Zookeeper saying, I am starting to access global catalog. And as soon as it finishes, it says I'm done with it. Okay. The other machine, you can now take one step again. Before going to access global catalog, it does one thing. It checks in Zookeeper how many machines are accessing it. In case that there are too many machines accessing it, that as per Zookeeper's record, it doesn't touch any of the global catalog. Now, if there are too many machines accessing global catalog, then it will wait till some of the servers disappear. Now, if there is a machine who marked itself that I am going to hit global catalog, and while hitting the global catalog, this machine went down. So this node, which is a ephemeral node, will disappear, and hence it will make a space for other people to again start accessing global catalog. Okay. So Shan's question is just more curious to know how it works internally when you say re-corrodication. What exactly happens in the coordination? Okay. All right, great. Oh, I answered it. Okay. Yeah. So, any questions? So, does it make sense to you? All right. Yeah. All right. If I try to draw again, it will become little more complex diagram. Each machine is talking to Zookeeper, marking its attendance the moment it goes to access catalog, and also noting the before going, it also notes down how many people are accessing the catalog and so on. All right. It's like having a temple in which only five members are allowed, so they all leave their slippers outside, and the quality about these slippers is in case you know even if I mean, how can I describe? Okay, this is a bad example, but nevertheless, they just leave their slippers outside so that other people don't enter the temple in case there are too many slippers outside. And as soon as people leave, they take away their slippers, and that's how it happens. So, these slippers which people are leaving outside is a sort of coordination mechanisms. All right. So, hope that makes sense to you. All right. Yeah. Now, so when you have to read data from an organized source, such as a database, RDBMS, MySQL, you may want to move this data to HDFS or HBase or Hive. Now, okay, yeah. So you will find it useful when you start building something. And Zookeeper is a very generic tool. It doesn't depend on Hadoop as such, but it's quite a useful thing. So when you have to move data from the relational databases to HDFS or into the Hadoop, then you would require a tool like Scoop. Scoop is basically, again, open source tool, extracts data from a structured data source into Hadoop for further processing. Can also move back data from HBase. So any database to HBase, Hive, or HDFS you can do, and similarly the reverse. So we'll give you an example in by showing you XML to HBase also possible. So for that you will have to convert HBase into some format. So I would do it this way. If I have an XML, use XML. I'm not sure if there is a tool already, but what would I do is I will actually load XML and convert it into my into a relational format using one of the readers in Hive. Okay, you will see that when we talk about the project sentiment analysis, our input data would be in JSON format and we'll convert that into relational. All right. Now, so the easiest way to SSH to any of the machines, Scoop is basically a client. It doesn't have a server. It's just a command line. It utilizes MapReduce to do all of this. And so, wise thing would be to get started right away. So let me SSH. Those who are not familiar with Bash, there are a few clever things you could do. If you press Ctrl R, you can search into your command history. That's what I was trying to do. So Scoop help would show you all the details. So there are import and export in general, and then there are list databases, list tables, and all other things. Okay, so one first question comes in that what all databases are supported. The answer is almost every database that supports JDBC. Even if it doesn't support JDBC, you can create a connector just like we have JDBC connector. So you can create a connector. It's a modular framework which makes it possible for newer databases to have their connectivity in place. Okay. Although it wouldn't be required because almost major databases are um, already registered with Scoop and they have a connector. It works pretty well. Now let's take a case that okay, and a few more things. So the way SQL this Scoop runs is the way Scoop runs is could I okay. Let me call it. All right. So the way it happens generally is that you have MapReduces which will be running on separate machines. You'll have one machine, two machine, three machine. These are your MapReduces will be running, and then there will be your database here. All of these map reduces will be talking to the same database and getting the data from that database. Okay. So you have your, the task trackers, or you could, and then on this side you have MySQL. Okay. So when you launch it, when you launch it, basically your scoop from here, when you launch this scoop, then it goes to individual task trackers, it creates the maps, and then it talks to this. Okay, so Abhinav's question is good. He says that MapReduce gets the data from standard input line by line. How to fetch it from database? So that is just one form of input. That's just one form of input. Your maps is essentially a program, a Java program, right? So Scoop library basically talks to MySQL. Scoop library creates each individual maps which talks to database directly. Okay, your map is essentially a Java code. It can do anything that Java can do. All right. So all of these maps, the task tracker will be hitting the MySQL, and it might actually overload your MySQL quite much. Yeah. So Scoop does it pretty well. Scoop does it. I need to understand exactly how does it do. So Abhinav's question is that when Scoop is talking, by the way of Scoop, each map job will be talking to MySQL and will try to get data from there. How would it distribute a big table such that some of the rows are read by one task tracker, some of the rows are read by second, and some of the rows are read by third one? Okay, so it does in some way, basically before it starts the process, it tries to query the table and accordingly distribute before it starts the MapReduce division. All right. No. So what Scoop does is Scoop basically is the launcher of your MapReduce program. You tell you tell Scoop that, hey, I want to import my table into HDFS. And then each of these task trackers, they will also be talking to HDFS. Okay, they will all be talking to HDFS as well. So here will be your HDFS. Okay. So Scoop will create these map reduces which will access MySQL, and then those maps, basically no reduce would be there, only maps would be there, and these maps will push the data to HDFS. Now question is, how does it divide? That is something I need to understand. I haven't studied that part. All right. Now this also means there are a few things when people run their MySQL, when their people run their scoop on the local virtual machine containing a single node, everything just works fine. When they run the same command on the when they run the same command on the cluster, it doesn't run. I mean, it happened to me in the beginning. And unless I understood this diagram, I couldn't figure out why isn't it working. What's wrong with my cloud labs? Why isn't it working? Reason being that we were quite used to setting up the virtual machine or setting up an existing setup. The reason is MySQL by default does not allow you the access from other machines for a newly created database. For that, you need to give the permissions for for each IPs. Okay, and that was the reason why it was not working. Same was the reason when we were running a couple of projects, we were also facing a similar problem. Later, when we thought about it, we realized that since it's going to run from multiple machines, are we able to connect from this machine to MySQL? If we run a command, MySQL command line to connect to MySQL server on the other machine, then is it running? Are we able to connect? So that way, that's the way you should be debugging your scoop. Basically, the biggest challenge you will face with scoop is this. Other than this, everything is very simple. All right. Okay. So Sushant's question is, how was the data transfer happening when we said Hive load data local path etc. Okay. So yes, that's a very good question. Okay, let me rephrase and explain what does this question mean to you. So when we say load data input path, we basically load this data into Hive. And as we discussed, that Hive stores the data in MySQL, the metadata, which means all these machines where the parallelism will happen, because Hive will use the again maps paradigm to load the data into the table, right, from these places. And which means that Hive would be connecting, your command would be connecting to MySQL from any of the machines, right? But good part was when we were installing Hive, the database it creates for itself has the proper permissions. Okay, so we'll make sure that while we do that for same thing for Scoop, we create a proper database with proper permissioning. So, was that your question, Sujant? Okay, when I execute the command, okay, yeah. Okay, so step one was done using HDFS, simply HDFS dot put. Okay, so using if you are just uploading files, it's okay to upload files just like that using HDFS or using any of the Hive way of importing data. Okay, but if you are handling the database, okay, and databases are fairly tuned for high throughput, and also database, yeah. Okay, so in case of Hive, the import or the copy of the data happens only on one machine from which you're launching the job. But okay, and you might be launching the job from any of the machines on which Hive client is installed, right? Which means And this Hive client has to store the information on the Hive meta store, which is actually the MySQL. Therefore, Hive database need to have the permission from any user. Okay, so everybody on the same page. So before we start, let's connect to the MySQL. Before we start, we will be first creating a database in MySQL. MySQL is a database. For giving example on how to import data, we will be first creating a dummy data. Let's say that we have a MySQL which is installed, and let's say we are creating a database called Scoop3. It says database exists. Let me just drop the database, and Scoop example 3. Alright, now let me just create the database created. Now here I am giving it the permissions to all the machines. It says, so MySQL is installed only on Hadoop 1. This is only on Hadoop 1. Okay, and this could be Hadoop 2, Hadoop 1, this could be Hadoop 2, and this could be Hadoop 3. So as long as you are only working on Hadoop 1, everything is beautiful, everything just works. The moment you start dividing work, your MapReduce starts running on this one, and the fourth one, then there will be a permission denied over here by default. If you create a database, okay, if you create a database, so this one will do good, this one will be okay, but this one will give an error in the default set of system. This one will give an error. Okay. All right. Now that is why I'm creating this database such that it connects to it. It says that grant privileges on Scoop 3 from localhost from anything knowbigdata.com. Ideally, this should have worked. Ideally, this particular command should have worked, but for some reason, since I'm not great expert on MySQL, I'm not able to make it work. Okay. This says that allow everybody the privileges to access Scoop EX3 from Hadoop 1 or Hadoop to Hadoop 3 from knowbigdata.com. Are there any permission for Scoop to create mapper on restricted Hadoop server? Okay. Not really. It is generally dynamic. Are there any permission for Scoop to create mapper on restricted Hadoop servers? Not really. It's just like when you launch something, Hadoop divides the job onto multiple nodes. In the same way, this will we're having the same mechanism. Okay. Now let me just give the permissions to all the machines. Alright, so great. Now let's create a dummy table onto the database. I say use scoop ex3, and then yeah. So when I say select star from widgets, I created a dummy table called widgets, inserted 3 records into it. So we have this, right? Now we've created a dummy data over here. Now the next step is let's import it into HDFS first. Okay. To import it into HDFS, basically I want to convert this table into say tab separated file. Okay. So I think I'll just create another terminal. Is everyone with me? Okay. So also let me have a look at this file called widget Hadoop fs-ls. And do we have widget? Okay, we don't have a widgets table. Instead, I would actually do. Okay, so if I say asgiri, so when we use a particular machine, can we not provide DNS so that permission don't have to? Yes, that's correct, but I don't know how to do that. Basically, what you're saying is the way here we have given the permission on every subdomain. Percentage means subdomain, and that's all. So every time you create a database in MySQL, you have to define the permissions on it. Okay. Now, so here we are trying to import this table into HDFS file called. Okay, so it's if you look at this command says that scoop import connect to this database for this table and then with this username. Here we are not specifying an HDFS file. By default, the HDFS file is the same name as the table name. So it says to you that preparing to use MySQL streaming and beginning the code generation, executing SQL statement, and so on. In case your MySQL required permissioning, you could have used the argument provided by scoop for username and password. So here you can see that this scoop has prepared one Java file as well. Also, it's using our MySQL manager, and here MapRed jar is being created. Okay, and it also gave us the URL to check what's going on, just like any other MapReduce job does. Okay, and as you can see from the reports, under the hood, it's actually running the MapReduce job. All right, it has finished. Now let's see if it has created a widgets file. So now widgets has been created. Now quickly somebody can tell me how to see the data inside widgets. So widget, okay. I'm saying so widget in HDFS is created. That's why we have to use Hadoop FS to see the data. Now under the part M0, because it's using a single reducer probably, it has imported our data in the form of comma separated file. Okay, so this is the file it has created out of the data pulled from MySQL. Okay, sounds good to you? So that is how you push the data from MySQL to HDFS. If you have to load it into Hive, you will have to create the same table in Hive also, right? With the same fingerprint saying column 1 is this, column 2 is this, column 3 has got this data type and that data type. That is little cumbersome. Instead of that, Scoop has provided you a way to directly import your table into Hive. Okay. So let's first create a clean table. So Seema's question is, if the data was pretty big, will there be multiple files? I'm not sure about that because it doesn't generally use many reducers. And let me see if you can have multiple reducers over here. Basically, question is that does Scoop use multiple reducers or not? Because anyway, if you think about in terms of the size of the file, this file is anyway on HDFS, right? So file is anyway distributed across the cluster. So is there any, yeah, I will give the demonstration of that also, Megha. How do you push the data from HDFS to MySQL? And the other question was, I guess the number of reducers will be multiple files. I didn't get you. Can we do the incremental import using Scoop? That I need to look into because in the import syntax, it doesn't tell you that. Maybe you might have to build your own way of doing it, maybe based on a date timestamp. So here, while importing, the way it provides to you is here. If you see Scoop import, okay, there it provides you a way to provide a query, meaning that you in the where clause you will say select star from this table where date time, I mean you will not say select star, you will say in the where clause date time greater than today, and based on that you can make that mechanics that it becomes an incremental system, right? Number of mappers you can define here. Okay, number of mappers, as we were talking, actually you can define it here. I'm just looking for, can we create number of reducers also? Although because there is no reduce process in the whole game. Okay, there is no reduce process in the whole game. Okay, so Ranjit's question is, I think mainframe to HBase not possible with Scoop. Am I correct? We have a okay. Let me ask you the other way. Is it possible to move data from mainframe to any of the JDBC databases? Is it possible to connect to mainframe using Java? If that is possible, then definitely it is possible. If you can connect to mainframe using JDBC driver, then you can use that same thing. Okay, that makes it interesting with CICS interface, not with JDBC. That is something need to be looked up. Okay, okay. All right. Also, it provides you an incremental kind of thing where you tell that it has to be appended. Okay, as you were saying. So there is an argument. Okay, okay, okay. Then it need to be thought about how could that be done. Maybe maybe you can do it in two passes. Or what you could do is basically write your own code in which, the way Scoop does, you write your own connector. Okay. Look for the connector for CICS in Scoop, you will get a connector definitely. Okay. Also notice that when we were talking about this in the current folder, a file called widgets.java is created. In this file is basically an ORM mapping. You can use this file again to represent your data. If you are trying to read the data from database. Now instead of you creating the whole table into Hive, you could use this command directly to say scoop create Hive table, connect to this database, and this table, and then you mark the fields by comma and create it in Hive. That's it. I'll show you this. So on one we have at MySQL, and here let me just so this one is first one is my MySQL, second one is Hive, third one is normal SSH from which I'll be running scoop commands. Here show tables already has widgets table, so we'll just say drop widgets. I hope it doesn't drop. It doesn't delete my Hadoop fs minus ls. Okay, widgets is there still, and Hadoop. Yeah, it's there intact. Now, so this is my MySQL, this is Hive, and this is my command prompt. Let me try to import the data. Import the table. Basically, it should create a table in Hive, widgets table in Hive. So here the widgets table has been created, the one which we just deleted has been created by import. Okay, it has created the same data types what we have in MySQL. Okay, now the only thing is that it is a blank table. Select star from widgets. I'm doing it in Hive, and right now we have not imported data into widgets. Also note that it is creating the data at this location. Okay. Now, to next step is load our HDFS file, load data input path HDFS file into Hive. Okay. So it has loaded the data which was imported earlier. Okay. So we did three steps. First, we copied the data from MySQL into HDFS. Second, we copied the table definition from MySQL to Hive. Third, imported the HDFS file which we uploaded in step 1 into Hive using load command. Okay, so this basically moved the table from HDFS to the warehouse, and now the data is available in Hive. So it involved like three steps roughly, and it little clumsy. Instead, what you could do is you can do everything in a single step. Okay, you can do everything in a single step. Let me drop table called widgets. Now it has deleted the local file also. Okay. Now it is going to import the data as well as create Hive table. Let's see what exactly happens with this. Okay, so it already exists. Let me just remove that file. Hadoop fs. Okay, quickly how to delete a folder in HDFS. Anybody? Yes. I want to remove that widgets folder which we created, which got created because of importing. Yes. All right. So good. So now it wouldn't be there, right? So let me just check. All right. So it's not there. Now let's import it. It says scoop import connect to this table and then Hive import as well. Okay, it will do all the steps in a single shot. What is the meaning of minus m arguments? Rm, it is minus rm. We are trying to delete a folder. So minus rm dash r, recursively delete a folder. Okay, meaning minus m, I'll show you that. So here it's a number of mappers it's going to run. Okay, let's just see the scoop import help. Okay, what does it mean by minus m? It's most likely the number of mappers. Okay, and you can also define that if you have a ID column in your table, you can utilize that ID column to divide the work. Okay, and it has all kinds of detail, like you can also, instead of doing select star from a table, you can define your own query statement that needs to be imported and so on. If you only want to import certain set of columns, you can also define that. So it's a quite flexible tool for you. Good. Now this way we were successfully able to do two things. One, in 3 steps we were able to load the data into Hive. Second, we were able to load the data into Hive using a single step. Next step is how to load the data into HBase. Okay, we'll talk about that also. So let's take a break for 10 minutes and come back at around back by 10. All right, so should we start now? Sure, Megha. I'll make sure that I read out the question. So I keep thinking that because everybody is able to see the question, I don't have to read it out. But since the session, recorded session, does not have this information about the questions, it becomes difficult for other people to understand the question when watching the video. So I'll try my best to repeat the question. Thank you for making sure that. Okay. So should we start now? Bindu, Nakul, Ranjit, Sushant, and Swati. Should we start now? All right, I think we should start. Okay, so in the similar manner, we could also import the data into HBase. So let's have a look at that. So instead of here connecting to Hive, let me connect to HBase and so we do not have the table over here. Okay, now let's start. This one says connect to the JDBC, this particular location. Okay, before that, I had a question from Sushant. Let me repeat that question. When you say load data into Hive, you are meaning have the info loaded in Metastore and actual data in HDFS. Yes, that is correct. Whenever we say that we load the data into Hive, we are basically informing Hive that hey, data is being loaded into this particular table, and it will accordingly keep the data at the right location, and that's all. Hive is nothing but Metastore, which is stored in MySQL or any other database, and data located at some places. All right, so here now I'm running that command. It says create HBase table, and let's have other part of the syntax. It says import this database from this database, import this table, and let's call a HBase table called my HBase table. Okay, actually my HBase table is already existing here, and column family CF1. So which column family should these columns go? That's all is required. Okay, and then you can provide the login password of your MySQL. So it has actually imported the data into the same table. And our table name is my HBase table. Here, scan my HBase table. Scan my HBase table. Alright, so it has imported data into this table. You can see the rows 1, 2, and 3, and it seems that when you import, it overrides the actual values. Okay, so here it says column family is this, price is this, and the table has been imported into Xbase. Alright. Now the next step is to take this data from Hive to MySQL. Alright. Let's say that so we were able to successfully load the data from MySQL to Xbase. So first we are trying to create a table in Hive called sales. Luckily we already have table from the last session which is created. So this is the table we are having in Hive, and we want to take this table into MySQL. And if it is there in MySQL, let me just delete it. Okay, so Abhinav's question is, but why do we want to export data from Hive to MySQL? Yeah. Now, not everything will have this kind of a. Okay, let me put it the other way. So I'm trying to answer Abhinav's question. Why do we want to export data from Hive to MySQL? The data in Hive may be in terabytes. That's a very good point. Okay, but there are cases. Say, for example, we will be showing in the second half that say you are writing a recommender. You wrote a recommender which generates maybe 1 gigabyte of data, hardly, and this data, or maybe 500 MB of data, and this data need to be displayed on your website, and your website is running a PHP and MySQL kind of a system. There you need to show it to the user that hey, these are the recommendations for you, right? In those cases it would be better that, because you do not want to expose your HDFS to any of the servers running in DMZ zone, I mean in the website zone in which you run your website, public website. So we call that DMZ, demilitarized zone, which is generally created such that if user has attacked your website, attacker has attacked your website, they won't be able to get into your local network. So, so that way, you would like to push your data from HDFS to MySQL, okay? Because you do not want to expose your HDFS to directly to your web application. All right. So in those cases, you would like to push these few gigabytes of recommendation periodically every day onto your web server. All right. Makes sense to all of us. And then you can continue to use it in Python, PHP, however you want to present, you can present it. All right. Now we don't have a table right now here in MySQL, but we have a table in Hive. We want to take this table from Hive to our MySQL. Okay. Now this data is already prepared. Now next step is that here this is a little bit of painful that we need to create the MySQL table by ourselves. If we do not have that, let's see what happens. Says that connect to MySQL, and we say export directory, and import will terminate it by this, hide this. So there should be some better way, I'm just thinking. How can you export? Because here, what we are trying to do is, we are trying to export. And we do not want to create our own tables. Okay, so export control argument, you have batch, you have call. Batch is indicating whether, okay, and okay, so there is no way we can import directly. So it says in scoop ex3, the table is already existing. And let's just drop the table. Use scoop ex3 show tables. Wow, so use scoop 3 show tables. And why does it say that way? Scoop ex3 say select star from scoop ex3 dot sales. Table not found. And why does it say here? It says scoop export my data from here to this JDBC location. My export directory is apps hive warehouse sales, which is okay. And then import. Let me see, what does it say. It should say table does not exist. Okay, yeah, that's what it's saying. It says table does not exist. So the only downside of this approach or the scoop is it doesn't create the MySQL table by itself. You will have to hand code this table by itself. So here we've created our table, show tables. So we have empty table right now. Start from sales, empty table right now. And then we go here and say import, export. Now it will, and why am I saying apps hive this path? Because that is where our, we say describe formatted and we say sales. So in hive, this this particular table is stored at this physical location and it is a comma separated most likely. Yeah, it is field serialization and this is comma separated. That's why we are saying terminated by comma. So I think this is successful, yes. And now you can see here that select star from sales, the data has come here from our hive. All right. So this way, basically, you will create a batch script which imports your data from a web server to here, which will do things like delete my folder, create a table if it does not exist, and so on. Can we create database table etc with student login credentials? When I ran the as my MySQL command in Hadoop too, it asks for password. I think so. See, for all of you, this MySQL database, the password of the root is blank, so you can use it. Alright? But don't damage anything. You can use it. Alright? From inside of student login itself, you can say MySQL minus u as root, and then you can use it. And also note that MySQL is installed on Hadoop one, and that's what we are using. We could also install MySQL on Hadoop too, and so on. Okay. But it just happens that we are keeping it on Hadoop one. Okay. So that's what is Scoop all about. So we did three exercises where we first tried to move the file to HDFS, then from HDFS to Hive. Then second, we did MySQL to directly into Hive. Third one was MySQL to directly HBase, and fourth example was from Hive to MySQL. Okay. On the similar line, you can do from HBase to MySQL. All right, sounds good to you. Next is Flume. Flume is essentially yes. Go ahead, Abhinav. Yes, import will fail. Export will. His question is, if we have a table, if Hive table has data types which are not compatible with MySQL, then the export will fail. That is correct. All right. Now, was it your question, right, Abhinav, or did I miss some part? All right. So now, if you have to, this was good. We were able to import data from our relational database and back and forth. Now, imagine that you have got few servers running, having the website, and every day all of these servers are creating logs. Okay. Now you want to continuously move these logs onto your central system. Also, you would be having in the same web application some there might be some scripts running in shell or something. They would be creating various kinds of error messages using Unix command syslog or using other mechanisms. Okay. Some would be using log4j in Java. If you have a .NET, you will have log4net and so on. Now, all of these logs, and then there will be Apache server which is running over there. So there will be different kind of error messages and logs being created all the time. And what you want is you want these all logs to be stored into HDFS. Okay. Because these logs will take too much of space on the web server, which may not be great. And on HDFS, you can keep on storing all of these logs happily. Okay. And to move these Apache logs into Using a pipeline onto a central system is what our Flume does. Okay, and it not only moves the Apache logs, it moves all kind of data from various locations to a central place. All right. Now, Flume is exactly a distributed, reliable, and available system for collecting and aggregating and moving large log data from different sources to a central data store. Okay, and also note that it is not only for large log data, it also helps in cases like downloading data from Twitter and downloading data from various data sources. I'll show you those demos. And okay, so it does in a lot of sense, it does a lot of things for you. So let's just get started with basics of it. And here you can see that the Flume is essentially a pipeline. It's essentially a pipeline, and these pipelines are built something using something called agent. An agent is comprised of a source, a sink, and a channel. Source generates the data, sink absorbs the data, and channel holds the data while between this conversation from source to sink. You define, whenever you're creating an agent, you first define your source. How does it generate the data? Then you define sink, how does the data gets written? And then you define a channel which will hold the data in between, whether it holds in memory or it holds on the disk. And there could be multiple kinds of channels, multiple kinds of source and sink. Okay. And there could be multiple sink also, and there could be multiple sources also for a channel. And this way, if you take these units, these are like pipes. Okay. If you use a modular vacuum cleaner, you will have these pipes which you can keep on connecting one after another and build a huge, similar to that vacuum cleaner. You can actually build a bigger pipe, smaller pipe, and whatever you want. And but this one is far more modular. You can keep on adding various kinds of pipelines. So does it use serializer, deserializer? Yes. It has its own serializer generally. The all communication from source till sink happen using its own binary conversion, and I'll show you that. Okay. It supports wide variety of sources. The source is something which generates the data, and who can generate the data? Maybe tail minus f. So what does tail minus f do? Anybody? Quickly. Tail minus f. Yes, yes. So tail minus f reads the last page. First it reads the last page and then it waits for the newer data to come in, and then it will start to print it on the sysout as and when the data is coming in. Okay, so tail minus f makes a very good use case for pushing the data continuously to a central place. So you might start, say, if there is a Unix system to generate continuously log for your system, you could use tail minus f. All right. Syslog is one another command. Log4j could be another source for Flume. Okay. And Flume could be used in arbitrary topologies to build a huge mesh network out of all the agents in order to take the data from various sources till the sink and sink and sink. Okay. and you can connect the source to a sink of another, and the pipeline will continue. Okay, typically there is a node running on each source machine, and with tiers of aggregating node, the data flows through its way onto HDFS. So generally, the general strategy is you have multiple machines generating multiple kinds of data continuously. You build these topologies such that each machine is having one agent, and this agent is reading the data from every sources and then sending it to HDFS. Okay. Now let's create a more sensible thing to do would be to create a Flume agent from end to end. Okay. So before we create Flume agent, let me talk about something called Netcat. Netcat is a nice service which basically connects, which starts listening to a one particular port, and you can read from there. So let's create. I already have a. Okay. So here we have flume.properties in our folder, which under sgiri underscore and then flume. It has few things. First is, okay, this is the single file describing our agent, and we have just arbitrarily named our agent as A1. A1 has got sources. Right now there are only one source. There is only one sink. This is my sink, and this is my channel. All right. So you have got one source, one sink, and one channel. Now let's describe what does it mean by R1. R1 means R1 is of type netcat, and it connects to localhost, listens to this particular port. Okay, it starts listening to this particular port. So any user who wants to write to this port, okay, who wants to push its data to Flume, they can start writing to this particular port. They can connect to localhost and then start writing there, and that will become the source for your agent. Okay, that will become the source for the agent if somebody is connecting to this port and writing. But before that, you need to start the Flume agent, and then Flume agent will start listening to this port, and then you'll all the people will be instructed that hey, write to this port. Okay. Now next step is to define what does it mean by sync. Sync, because we want to write the data somewhere. So right now we'll just tell it to write the data into this particular folder. Okay, it writes the data into this particular folder. And what kind of channel do we want? Okay, here we are saying use the channel which is in memory. It has the capacity of 1000 elements, and that's all. Okay, so that's our channel description. Source is the one which will be generating data. Here it's generated by the way of listening to a port, and Sync will be sending the data to the HDFS, and channel will be holding the data between reading and writing. While the data is being read from the source, it keep on getting written into this queue called channel, and sync keeps on reading it from the channel. Okay. And after you have defined your source, sync, and channel, now let's connect them. Let's inform source about the channel. We are telling that sources.channel is this. Now Now source knows about its channel, which is C1. So R1 will start writing to C1, and here we are saying sync to the sync dot this is this one, which means sync will start reading the data from HDFS and start doing. Okay. By the definition parameter, all the Sushant's question is, all the definition parameters are user defined, or there is a prototype like port. These are prototype. These are the predefined values. You can have more configuration at their website. Okay. So more definition you can get on the website. What kind of various? These are various different kind of source and sinks. Okay. The only thing you can change is port number and localhost and maybe type. It's a predefined set of types. All right. Now let's start the agent. Okay, let's go back one step up. We have got conf folder. It has got these values, and also delete. Let's delete the data located here. What is that location? We have as Giri Flume web data. So we say ls as Giri Flume. Okay, so let me just say RM. I'm deleting everything inside that. Okay, it has been moved to the trash, which is deleted. Okay, now let's start the agent. The way you start the agent, you call this command line called flume ng agent and then pass the config directory and also mention that this is a config file and so on. Okay, now there. So it's running the flume. So now you can see that created server sock. Here it has created a service which is listening on this port. The source is listening to what you say here. So if I say nc localhost and what was the port number? 44444. Okay. Now if I keep on writing, it's actually getting written onto HDFS. Okay. This is getting pushed into HDFS continuously. I'll show you. So asgiri and then flume is the folder. Under that web data, it has been created just now, and you can see that it's in some binary format, and you can see there is a message written over there. So it writes in the format of in the long writable, and you can decode it using a deserializer, Hadoop deserializer. Okay. So Ranjit's question is, so we have to install Flume agent from where we want to push the log data. That is correct. Okay. So basically whatever we did, the data got pushed onto the server. Now it has created some other temp file. It's writing some data. Alright, now you can see I have typed quit and everything. It's moving data continuously into HDFS. It's more or less like a streaming data. Okay. Alright, so here I'd like to show you some more things. Alright, now this is the Twitter config file using which we downloaded the data from Twitter. Okay, it shows that there is a class called Twitter source, which is by Hottenworks. We are using that one, and then we are saying use the memory channel. And there are two sources, Twitter 1 and Twitter 2. Right? And here there are basically two Twitters with the same account. Login ID password is same. It's just that here we are using different keywords to search, and here we are using different keywords to search. Okay. So on Twitter we are searching. There are two Twitter inputs, two Twitter sources, which basically will be running parallelly and downloading data for you. Okay, and then we created a MAM channel, our own sink, and which basically writes the data to here. So our sink is HDFS sink, and it writes data. And after that, we configured further sink, the information about sink, in what format do we want. If we want to keep it in the plain text, we can do this. And okay, and then we start this agent, and this agent will be downloading data from Twitter and will be pushing all the data from Twitter continuously into HDFS. Sounds good to you? So that kind of systems could be built in a complex format in using Flume. All right. Yes, of course. You can have multiple instances of Flume writing into same sink, as in different agents writing into the same sink. Yes, of course. So it all depends on the one which we are using, the driver. It will be making a call to Twitter, and Twitter will be giving output, and you will be reading from there. Okay. So you can see the batch size is there, the roll interval is there. So it will basically make a single call to Twitter, and Twitter will start giving you the data, and it will start reading from the Twitter's that TCP connection, and start pushing it to HDFS. Okay, so you can see that the keyword here, you can see we are defining, go to the beginning of the file here. Twitter 1, Twitter 2 is the two sources. For Twitter 1, we have said these are the keywords. Can you see the keywords? I'm answering to Sushant's question. You said, where do we specify the keywords in Flume? So that is one. Then there is another source which basically downloads data from regarding Iron Man, okay, and so on. Okay. All right. So I'm skipping Uzi today. We will discuss Uzi maybe tomorrow. I would like to discuss Mahat today. We have 30 more minutes, so we can actually discuss Mahat, and we can discuss Uzi maybe tomorrow. And tomorrow I would actually like to go for uh, Spark, okay, and then Uzi. So these are the private tokens. So whenever you sign up with Twitter, they will generate a API key on these tokens, and you can utilize this particular config. So this information you can have a look at it is here, home student sentiment plume, and if you sign up with Twitter in the API section, you can say Twitter API, and Twitter does not give you the full data. They generally give you a small sample. They generally give you this API, these API keys after you log in. I don't remember my login actually. Okay, so they would provide you the API that you can use. All right, so the next level of things is Mahat. Once you have cleaned the data, imported, and brought it into shape, the next thing would you like to do is the ultimate objective is to churn it to give you beautiful insights. Okay, and a lot of things could be done on top of this data. And Mahat provides you a library of such functions which do a lot of machine learning on top of your data. So Mahat is essentially a machine learning library on Hadoop. It was on Hadoop earlier, but now it's general and it's written in Java. It's basically on a paper by NGETL called MapReduce for Machine Learning on Multicore. It all started as a Lucene sub-project but became Apache top-level project in April 2010. And in literal sense, it's a Hindi word. Mahat is a Hindi word, which means the person who tames or who keeps or who drives the elephant in the zoo. And the reason is that Hadoop is an elephant. Okay. So what exactly is machine learning? Machine learning is a sort of making the computer learn by itself, providing examples and let computer learn by itself and start doing the predictions. Okay. Yeah, we have zookeeper, we have yeah, Hadoop, elephant, and we have what else we had? We had pig, we have bees, beehive, and okay, so it's essentially a zoo. Okay. So maybe somebody would be writing duck or cow somewhere, some new tools. All right. Yeah. Okay, so in machine learning, it's a branch of AI. We design and develop algorithms and to basically let computer evolve its behavior based on empirical data. Okay. So in very, very simple words, if you ask me, the most basic form of AI or most basic form of learning would be your okay. So the most obvious form would be that you are given three data points. Okay, you are given three data points. One, this, other this, and other this. Based on this, you created a graph using the basic mathematics. You created a graph fitting and you created this kind of a graph. Now this graph is able to predict the future. Okay. What does earlier what we had was we had some values of x and y. For a value of x, we knew some values of y. Okay. We knew some values of y. For a value of x, we knew some values of y. Now, once we have plotted this graph, we are able to automatically predict the values of y which we did not know based on the data. So this is probably the most basic form of machine learning you can think of. Okay, we trained it earlier with 3 points. We trained it in the sense that we generated a graph, and then it's doing a lot of job. Given an x value, any x value, it's giving us the y value. That is the most simple form of machine learning. Okay, there are there are these three basic kinds of machine learning: supervised, unsupervised, and semi-supervised. Supervised is in the beginning we supervise that this email is spam, this email is not a spam. So we have this fixed label in which we train our computer that this is a spam, this is not a spam, this is a spam, this is not spam. And once we are done with that, it will start predicting after some time. Given an email, it will start predicting that this is a spam, this is not a spam. All right. So such kind of mechanism is called supervised learning. Unsupervised learning is you had bunch of emails and you say categorize by yourself. You build this algorithm, you just feed it a million emails, and it automatically creates that these are the five different categories I have come up with, and some of these emails lie in first category, some arbitrary name of the category, and so on. So that is called unsupervised learning. There is no labeling we have done. We are not, say for example, there is news. Okay. You downloaded news from say 500 sources across internet. Now This all 500 news from all these 500 channels, you gave it to Mahat, it will automatically try to figure out which news out of this belongs to the same, which news out of news articles out of this belong to the same incident, and group it automatically. This is called unsupervised learning. And then other case is semi-supervised, where you may or may not provide hints on learning. Sounds good? There are many applications of machine learning. And few years back, there were no takers of machine learning. The reason was the data was not significant enough to do the predictions in machine learning. But now the science has also improved. Science of machine learning has also improved. Along with that, there are humongous data available on which you can train your computer. Okay. As we were giving you an example of graph fitting, the more the number of points, the better is your graph. All right. More the number of points, the better is the graph. Now here are some of the applications. Say, for example, you want to recommend friends, you want to recommend dates, and you may want to recommend products to the end user. So, recommendation is one of the primary things which people do with Mahout or any such machine learning library. All right, and so these are these are the few examples of recommendation engine. And recommendation engine are also known as collaborative filtering. And the other use cases of machine learning could be classify content into predefined groups, as I was telling you about the news aggregation. And other is find similar content based on object properties. Okay, so I was looking at one company. What they do is they point the phone to your shirt, take the photo, and based on where is which then it tries to find out which e-commerce company is selling this particular site shirt. Okay, so that is all done. You basically figuring out based on object's property and all of that. So find the similar content is quite very big problem and is solved basically using machine learning. There are many use cases of this. Okay. Identify key topics in collection of text. You have a big blog and or there is a big blog or there is a big website in which you want to quickly tag things, that these are the 5 tags that define the whole blog article. Okay. To do that, you could utilize machine learning, detect anomalies in the given data. Okay. You are given huge data. You could figure out that this data is made up and this data is manipulated. Okay. So for that you could utilize machine learning. There are many examples like ranking search results in user feedback and classifying DNA sequences based on a certain pattern and doing a sentiment analysis or opinion mining, and then computer vision, face detection, and all of that. Natural language processing, understanding a meaning of a sentence, and bioinformatics. There are many use cases, even a simple thing like speech and handwriting recognition Most of these algorithms are heavily aided by training data. Okay, you train them for a particular accent, for a particular geography, and then it starts recognizing handwriting and speech. Okay. Hadoop is only Had, so Mahat, Seema's question is Mahat is only on top of HDFS or any database. So right, basically Mahat runs on top of the data, which is quite humongous. And it earlier was only for Hadoop, but now it runs on things like Spark and other places also. So yes, so this is a little complex part of Hadoop, but good news is that most of the complexity is absorbed by Mahat itself. Okay, and you will understand that in a minute. Now, based on data size, your classification, your tools, how you churn your data changes. Okay, when you had few lines of data, a whiteboard was more than enough. But when it became few KBs, you needed an Excel sheet. You needed an Excel sheet, you needed a MATLAB, Octave, or R. But if your data grows beyond KBs, goes to MBs, you would require NumPy and SciPy and other things. Okay? And if your data goes into gigabytes, then you end up having things like Giraffe, MLlib, or Mahat. Okay, so we will take an example of Mahat for our similarity lookalike. We'll take a recommendation example, and we'll be using an algorithm called similarity log lookalike. There are many other algorithms, but this one is quite simple. And so basically, Mahat will give you the recommendations in a format that person Kumar likes this movie this much, Sandeep likes this movie this much, based on the input in this form. All it requires is these three columns: the user ID, object ID, and the rating out of 10. Okay? And it will give you the rating out of 10. Sorry. So this is a pretty simple example. So let's start. Let me just, okay. As an exercise, before I move to the next part, you as an exercise try to run all of this. Okay. Create the data from MySQL to Hive and back. Okay. And Uzi you don't have to touch. And also explore the big data sets available from Amazon. They will come up and come up with some problem if you want to solve. I will help you as much as I can. Okay. Now let's take a case of Mahat's recommendation. We will build a recommendation engine which will give a insight into how does it work. Okay. So let's before doing that, let's just download this file. These are 1 million ratings of movies, and we are downloading from a website called Movie Lens. Okay. And after you download it, I think I have already downloaded it. It has been deleted. Okay. Unzip movie lens. Oh, we don't have. All right. So, or we already have uploaded it. Hadoop fs minus ls. So yeah, I have with this. So I've already downloaded that file and unzipped it. Here is the list of files. Out of this, we will be dealing with movie.dat. Okay. Sorry, we will be dealing with ratings.dat. Movie.dat contains the information about movies. You can see that. The first one is ID, the name of the movie, year, and the genre of each movie. And there is users.dat. It tells us a little bit about the user, their age, their gender, and then on what date the account was created. Okay. And inside ratings.dat, you will see it has basically a relation between which user dated which movie on and how much on what date. Okay. This is out of 5, all of the ratings. Okay. So you can see that. Okay. So now we have got this file containing all the ratings. Now what do we want is we want an comma separated instead of double column separated. And we don't want the fourth column. We want only user ID, product ID, the rating. Okay. What will we do? What should we do actually? Tail ratings.dat. Okay. We want to bring this format into our this format. Okay. We want to bring this into this format. What are the things I could do? Can anybody suggest me? We want to bring this format into this form. Instead of double column, I want comma there, and I don't want the fourth column. Because why? Because our Mahat expects the data input to be comma separated. Fourth column is the timestamp when this rating was given by the user. Okay. Abhinav says awk. Anybody else? Yes. Julie says regex. Okay. Okay. Regex with what? What tool are you planning to use? Okay. Ranjit says load using pig. Good. Okay. Anybody else? How would you convert this format into this format? All right. So, okay. It should be a non-interactive one because this is going to be a batch process and it has to run in the background. Okay. Now let me rephrase my question now. So some of you have said pig and some of you have said awk. So which one would you prefer? And what's the difference? It depends on how big the file is because if the file is few GBs and you try to use awk, what will happen is for running awk, you need to bring the file from HDFS to the local file system and then do the awk. And in this process, a lot of time will go into copying the data from one location to another, and that's where you'll waste a lot of time. Also, a single machine is not good enough to do all kind of churning. It needs to be done on multiple. All right. So that is fine. That is fine. So, all right. Anybody else? Okay. Okay. Good. So if you try to write using MapReduce and it will be a little much of the headache. But an approach with awk in a streaming job is a far better approach. Good, good. Now, yeah. So I like the approach using pig, but you could also use something of this sort. This is okay if you have few hundred, you know, a few hundred ratings, but if it goes for if the file goes beyond few GBs, it will be very difficult. Okay. So as an assignment, you can actually try to do it using pig. And for this, I can do Hadoop fs minus cat. All right. So, or you could simply do this. But I would prefer to do it on pig. All you have to do is use the pig catalog, use the pig storage and put the colon as the separator and then pick first, third and fifth argument and that will be good. Okay, now we have ratings.csv. Okay, the next step is you upload this into your folder. Okay, the file already exists, which means nothing to worry. And once you're done with this, once you have these columns in the CSV file, you can start running the Mahat in this manner. You say, Mahat, this is what I want. I want to generate recommendation, item-based recommendation. Item-based as in, I have user ID, product ID, and ratings. And all I want is to generate recommendation. And which algorithm I want to use? I want to use this algorithm. Okay. Similarity log likelihood. I would not go into the details about how does it do it because that will be beyond the scope of the session. So, and this is my input file. All right. Now let it run. So after it has finished running, you will get the results in this format, that this user can should be recommended these movies, and the chances of this user liking this movie is this much. Okay. By default, it gives around 20 ratings per user, which can be tuned. Okay. There are other recommendation algorithms which are of this format. There is Tanimoto coefficient is 1, log likelihood is 1, and co-occurrence is 1. Okay. There are many such, one is Pearson correlation. I think this was the one which was invented during the event by Netflix. Netflix organized a competition for coming up with the best algorithms, and AT&T Bell Labs guys won that competition of $1 million. Okay. All right, so it is doing something. It says that output directory already exists. Let me just drop this folder. We have tmp this folder. Let me just drop this. Hadoop fsls. All right, now let me run it again. It might take some time, but once it's done, you will get a result in this form. And once you get this result, you might want to move this to your web server where you want to present it to you, the user, and or in other format. All right. And these are the few things which we have discussed about. Mahout has classified all its algorithms into these four categorization. It has many algorithms. You should have a look at Mahout's website. Okay. And the algorithms which Mahout has are vaguely categorized into collaborative filtering, which is recommendation, clustering as in given a set of article, how does it bring the various items together, classification based on a predefined labels, can it apply labels by itself, and then frequent item set mining, that is another separate category. Okay, so when you add things into your shopping cart, can if you have to give a recommendation that if you buy these five things together, you will get this much discount. So that kind of a recommendation is a different one than the normal one, and for that there is a different category of algorithms altogether. Okay, so let it run. It is going on. Our map reduce is going on. It might take some time, maybe half an hour more. All right, so give it a try. Try to first clean up your data using pig instead of using command line. Try to do the whole exercise of downloading the data, cleaning it up, and running Mahout by all by yourself. Okay, that will give you the far more confidence that you could start with raw data and reach to the recommendation. That will be a good thing. Okay, so try doing this end to end by all by yourself. Okay, and once you are done, let me know. Okay, that's pretty much for today. Tomorrow we are going to discuss a very important and exciting technology called Spark, and we will go through a command line mostly, less theory, more real life. How do we solve the problem using Spark? Okay, are you with me? Because Spark is something which is coming up and is proving itself to be better than MapReduce. And that is why I had included Spark with real life examples. I mean, with the live session. So don't miss tomorrow's session at any cost. All right. Yeah. I will look at the forum questions and reply. Yeah. Ranjit, we can take the discussion. Actually, lots of people are waiting for the data science course, and we are yet to plan for the data science actually. Okay. We'll keep you updated about data science course. All right, then thank you very much and have a good day. All right. Thank you all. See you tomorrow and we'll have a good discussion. And in the meantime, go if you want, you can go through the previous sessions videos so that you're better prepared for the session and we can I mean so that it becomes more interactive and right. See you tomorrow. Bye bye. But do run the recommendation example by all by yourself. Make sure that you run it by all by yourself end to end. Okay. And some people would like to run it, install the whole thing end to end, install a virtual machine, download the data, and do everything. That's also a good approach. Okay. See you then. See you tomorrow. Bye bye.